Okay, so let's do our next example with the same data set. Now we're going to do the TV weekly viewing times for 20 people in hours. And before I go on with this, I want to correct a mistake on the previous one. My impossibly horrible ability to subtract numbers without a calculator has struck again, which is that I said that 36.5 minus 23 was 10.5, but actually it's 13.5. So you can check me with the calculator if you don't believe me, but I just checked myself with the calculator. So we're 13.5 is what the interquartile range was for our previous example. And that's going to matter for the next problem. So now I want to identify any potential outliers, and I want to construct a box plot for the data for my 20 viewing times. And here's the data again sorted. And here's all 20 data points. And when I look at this, some things immediately pop out to me. One is this 66 as something that could be a potential outlier. So which of these numbers don't belong together, right? Sesame Street, all the way back. What are these numbers? What's not the same here? 66 is a full 23 higher than 43. This is a big number. This seems to me like an outlier. If I go down here on the bottom end of the data, I have this 5. And 5 is 10 number than 15. It's not quite up to 23. It's not as much of an outlier as here, but I'm going to flag 5 as another maybe potential outlier. So just sort of looking at the data, I have this sort of visual idea that maybe 5 and maybe 66 are outliers. And all these other numbers, they're pretty well clustered together, right? There's really not more than 2 or 3 between any of the other data points. So none of these other data points really seem like outliers. So in your book, we have a kind of more precise way of answering that question with lower and upper limits. So let's do an example with the lower limit. So we're going to say that the lower limit here is going to tell us the number below which all of the other numbers that are below that number are outliers. And let's do this in pen so it works a little better. So this is equal to Q1, the first quartile, minus 1.5 times the interquartile range. So that is my 5-number summary, just to remind you. For this data, we found to be 5, 23, 30.5, 36.5, and 66. Where this was the min, there's Q1, Q2, Q2 is also the median, Q3, and the max. So our lower limit is going to be Q1, 23, minus 1.5 times the interquartile range, which is Q3 minus Q1, which is why I had to correct my mistake before, which is 13.5. And if I subtract those, do that multiplication, I get 2.75 hours. So anyone who watches less TV than 22.75 hours is something we're going to identify as an outlier. This 5, by that definition, does not count as an outlier. So 5 hours is not an outlier. We're not going to include it as an outlier. Because it sort of falls in this range where we're looking at the lower quartile of the data, and we're looking at sort of the lower quarter of the data minus kind of 1.5 times this interquartile range, where if you remember the interquartile range is the thing that encompasses half of the data. So it's sort of like 1.5 times smaller than the 25th percentile. If it's 1.5 times smaller than the 25th percentile, then let's call it an outlier. If it's not, let's not call it an outlier. So the upper limit is going to be Q3 plus 1.5 times the IQR. So Q3 is 36.5 plus 1.5 times this range, which we found to be 13.5. And that is 56.75 hours. So anyone who watches TV more than 56.75 hours, we're going to call an outlier. So 66 here counts as an outlier. 5 does not count as an outlier. So this here is an outlier. So our only outlier is 66. Okay. And now the other thing is that we're going to construct a box plot. So in order to construct a box plot, we are going to imagine drawing a box with either the 5-number summary or with the 5-number summary in it or some information about some outliers. Okay, so we're going to start out with, we figured out our quartiles, we determined some outliers, and we're also going to call this 43 here an adjacent value. So because we have an outlier of 66, we're going to treat this differently than everything else. So we're going to kind of think about this 43 as being a meaningful number on our box plot. So we're going to need that. Down here, we're not going to need any adjacent values, and I'll explain what I mean by that in a minute. So we have our 5-number summary, which is these 5 numbers, and the other number that is going to matter to us for constructing this box plot is 43, this adjacent value. So let's draw a number line that goes all the way from 5 up to 66, and that's what we're going to use for our box plot. So here's my line, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and 65, and there's where my 66 will go. So here's my number line. And we want to have a single kind of whisker plot. Some people would call this a whisker plot instead of a box plot. That encompasses all of these sort of numbers that represent our data well. So our median, that's 30.5. So let's put something right here at the location of Q2. Our first quartile, the 25th percentile, that's 23. So here's 20, 22, 3, that's about there. There's Q1. And our third quartile is 36.5. That's about here. We'll put that up there. There's Q3. This is our box. The box part of the box plot. So it tells us that the data, and remember, between Q1 and Q3, we have 50% of the data. So half of the data is here, where Q2 is the median. Down here on the bottom, we have 5 as our lowest data point. So let's mark that. Up here at the top, we have 66 as our highest data point. That's all the way out here. But we specifically identified 66 as an outlier. So we're going to treat it a little bit differently, and we're going to call it a star. So we're going to write that as a star there. And instead of putting instead we want to think about this adjacent value as being a 43. So if we didn't have an outlier, we wouldn't have a star here. And this we would just have as whatever is the maximum value. So what we did down here, right, where we don't have an outlier, and our box plot now has the 5-number summary on it, the minimum, the maximum, and the 3 Qs. But because we have this outlier, we have an outlier and an adjacent value. If we didn't have an outlier, then we just plot the maximum value right here. And now we want to draw a line to connect them. Oops, that's not a very nice looking line. So our box plot looks like this. So we have the 3 quartiles plotted, the minimum value and the maximum value, Only here, since our maximum value is actually an outlier, we've plotted the outlier all the way out here, and we've plotted this adjacent value, the next closest number that isn't an outlier. And now I have a really quick and easy visual way to look at how this data are spread out. We have pretty tightly clustered around in here. We have this long tail on the left-hand side and a short tail on the right-hand side with some guy who just decided to watch every single episode of every single television show that has ever been made all in 1 week. And so this is a nice way of visualizing the data. And we can actually tell right now, just looking at this data, if the data are symmetric or skewed to the left or to the right. Because this distance here is very long compared to this distance, I can tell that this data is left skewed. So if I were to plot a frequency distribution of this data, I'd expect to see something that looks like that, where it has a long tail on the left-hand side and a short tail here with single outlier all the way out there on the far right. So that is taking data. We identified the five number summary, and we used the 5-number summary to construct a box plot. And in order to construct the box plot, we had to take into account that we had one outlier in here. We won't always have an outlier, but you have a lot of problems on your homework that are doing this sorts of thing. And in class, I will show you how to do some of this stuff a little bit faster, so you don't have